Tonight, I want to talk to you about the stuff that's been happening in JavaScript over the last, say, about 3 years. And I could spend quite literally multiple days if I wanted to cover everything that changed from ES6 onward. So we're going to only look at a few select bits. This is not a comprehensive list, and I'm not teaching you a workshop. We're not going to get into all the complexity of the code and all of that stuff. There's a whole lot of variation stuff. This is actually selected bits from a full-day workshop that I do on this specific topic, because it takes a lot to get into all of those details. The full feature list for ES6, many of you know, was like 40 or 50 features long, plus who knows even how many hundreds of minor little features and tweaks and stuff. So we don't have time to go through all of that. I'm literally just going to select a couple of small little bits to pull out and talk about in each of those. But we'll talk about a few things that set us up from ES6. And what I'm really trying to do is tell a narrative here about JavaScript the language, because I've been at JavaScript for a while. My first JavaScript was around 1998. I was working on a couple of different web page projects. I built a few projects for some clients, and I worked on a project at my university and stuff like that. So my first exposure to JavaScript was in 1998, and it was not a great language back then. And I, like many people, looked at the language and thought, well, okay, so I can do a few little toy things, but this is not the same as like a real programming language, right? And if you think about where it is now, over 20 years later, it's a lot different of a language. It has vastly more matured, more so than I think anybody. In fact, the long list of naysayers that have been betting against JavaScript and betting that it would reach its conclusion and couldn't go any further and couldn't be any more useful to the community, they've been detracting from JavaScript the whole time. And Brendan Eich famously says, keep betting on JavaScript because it's a good bet. It's a good bet that keeps paying off, because JavaScript has proven up to and exceeding the task every time that somebody's put that challenge in front of it. And there are people today that say JavaScript is over, JavaScript is done, JavaScript is on its way out because we have WebAssembly, and that means we can do all these other languages. And yet, I still feel pretty comfortable in my career of focusing on JavaScript. You know, I regularly get people come up to me and they say, have you tried Elm? Have you tried this? Have you tried Rust? Have you tried that? And I get excited by those just like everybody else, and I read the blog posts about it, and I'm like, cool, but I'm still trying to figure out JavaScript. I'm still at it. I'm still working on it. And I don't really have a lot of brain power left over from trying to figure out JavaScript to dedicate to learning some other language. There's lots of other people out there that can focus on that, but I'm kind of all in on JavaScript because I think it has proven that it's part of the DNA of what we're going to do as developers. For as long as I'm worried about, as long as I'm going to have a career, I'm not worried that someday all of this investment in time to understand JavaScript is going to somehow not pay off, or it's going to somehow go away. It's going to evolve, for sure. And we're going to be looking at different paradigms before too long. I mean, we're already talking about what does it mean to run an app on my watch and my phone and my TV and my refrigerator and my light bulbs and everywhere in between. We're already talking about that stuff, and it's changing the game. But I think JavaScript has proven that it's going to be in the mix of all those discussions, and will continue to be so. So I think it continues to be a really good bet. And so the narrative I want to talk to you about tonight, not just show off a couple of features, show off a couple of code snippets. Certainly this is not enough for you to like understand each of these features. There's a lot more to it. But I want to talk to you about something that I don't think that we have fully embraced as a community, which is the idea, and it really goes back to why I called the books the You Don't Know JS books. Because I often get questions about that. What did you mean by that title? Is it an insult? I've had people be offended. Maybe you're offended. You're in the room and you were offended by that book title. I've had people tell me to my face, I'm offended. How dare you say I don't know JavaScript? You don't know me. The meaning to the title, there's multiple layers. There's the joke, what JS could stand for if it didn't stand for JavaScript. There's the joke. But there's really a deeper meaning layer, which is the idea that nobody actually knows JavaScript. Not completely, not fully, not entirely, not even Brendan Eich. He created the language, is still intimately involved in progressing the language. But I am quite certain that I could pose some sort of quiz to him or I could trip him up. And anyone in this room could pose some quiz to me where you could trip me up. Matter of fact, multiple times over the last several months, this happens about once every month or two, I'll be at some event, some meetup, some teaching or something like that. Somebody will come up to me and they'll have my book in hand. This gentleman down here has a copy of one of my Jay's books, and they'll say, well, here on page 37, you say this, and I don't understand how that is. And I get this sort of like glazed over look in my eye, where I realize quickly I don't remember what he's talking about. I don't remember writing that. Clearly I did. It's my name on the book. So I obviously did write it. I don't remember writing it. And I don't remember what the context was, and so I have to remind myself. I literally have to go back and read my own books to remind myself. I'm going to say something that might sound a little bit like stuck up, but it's not intended that way. I have forgotten more JavaScript than most people have ever learned. And that's the truth, because it turns out to write authoritatively about a language that is so expansive and that has so many different constituencies requires an awful lot of learning. And I learned all the ins and outs of it, and fortunately I documented that journey in the books, but I can't keep all that stuff in my head. I still get tripped up, and I think the same would be true of any developer. And so one of the things that I want to tell in terms of what this talk is about, one of the narratives that I want to tell, is embracing the idea that it's okay to be uncomfortable with not knowing all that stuff. As a matter of fact, we have sort of a paralyzing effect that has happened in our industry, where this Cambrian explosion of new tools and new frameworks and new acronyms and all this new fancy stuff, where it used to be that to write a JavaScript program was to just put a line of code in Notepad and then bam, it's on the web, right? FTP it up and it's on the web. And now we have this immensely complex process in between writing a line of code and it's showing up running inside of a browser. And there are many people, and I confess that I'm one of them, who feel intimidated by that. I am dead serious when I say if I were to go for a JavaScript interview today, I could not get a JavaScript job today. I could not. And I don't feel bad admitting that to you. Because they would say, all right, well, to set up this coding test, I need you to like configure Babel and Webpack and all this other, and I got nothing. Right? I know what Babel and Webpack are, and I've used both of them, but if I were to go, if my job were literally to be on the line, could I go and properly configure this and set this up and get it all working? I couldn't do it. Could not do it. And so I understand when people feel intimidated by the complexity of the ecosystem that we've set up. Some call it complexity and some would call it maturity, but whatever label you use, the scaffolding of what we do is significantly more involved than it used to be. And people sometimes feel a paralyzing effect, like I get people saying, well, how do you keep up with it all? I get that question a lot. How do you keep up with all this stuff? And my simple answer is I don't. I don't keep up with it all. I don't know all the nuances of all those different little things. You could probably come up with 15 different libraries that have been launched in the last week, and I haven't heard of them, I haven't looked at them yet. But what I try to do is keep an awareness about the ecosystem, about the trends, where things are moving, and the big major movers and players and the bigger narratives that are happening. That's what I try to do. So I understand where Babel fits in and where Webpack fits into the overall ecosystem, but I don't have a specialty level of understanding of any one of those pieces. The one piece that I chose to specialize in is JavaScript. And so I want, as sort of a meta layer that you take away from our talk tonight, I want you to start realizing that it is okay to say, I don't know it all, and I never will. And I don't need to get to some point where I can get the check mark on my spreadsheet to say that I know it all, but rather to embrace this constant idea of evolution and change. To be okay with that, to be okay with the fact that these things are changing. Also, I'm going to show you something today that you've never even seen before, because you didn't know that JavaScript did this like last year or something. And that's not designed to like make you feel behind. It's actually, my intent is to inspire you that there's this constantly changing, evolving thing that's a good bet. And you should get on board with that train and keep learning that as much as possible and keep exploring and pushing forward and be part of the process. Provide the feedback to the committee, to the TC39 folks, to help them define what's happening with JavaScript. It has a rich history, but also a rich future. There will be lots of things changing, and some of them will be great features, and some of them will be terrible. They inevitably have done some really bad things that I don't like. But when you take it as a whole, this is an exciting ecosystem to be part of. And it's exciting, I think, specifically when you get off that, like, oh, I can't possibly learn all that stuff. When you get off of that and say, I can be aware of those things. I can be aware that there's that thing, but I don't have to be an expert on every framework, or every tool, or every pattern, or every acronym. And you don't have to be an expert in every feature that we talk about. But being aware of the ebb and flow of where the language is headed. Being aware of what WebAssembly means. I mean, we don't even really know what WebAssembly means, but just thinking about it and talking about it and exploring it is something that not just the Brendan Ikes of the world need to be doing, all of us need to be doing. Because quite frankly, I'm a little concerned that we're not responsibly talking about what something like WebAssembly is going to mean for the future of learning web technology. I mean, I'm very excited about what it means for how much faster applications will load and run. That's exciting. But there was a day when to learn the entirety of the web could be done with a single view source click. And you could see all of the HTML and all of the CSS and all of the JavaScript in one file. And you could learn those simple pieces and replicate the same on your site. That is how I learned the web. And it's how many people learn the web. And I don't think, I mean, sometimes it's the punchline of a joke, the idea of view source today. But I don't think we should be so quick to dismiss the idea that view source matters. The idea of view source matters, whether the implementation matters or not. The idea of having accessible paths for learning. Is our answer to the future of learning the web be like, well, you got to take a 12-week boot camp on HTML, CSS, and JavaScript, and another 12-week boot camp on Go, and another 12-week boot camp on Rust, and another 12-week boot camp on fill in the blank, and then you'll learn the 7 different technologies that you see when you click view source on this website. Well, what does that mean? Does it mean that people coming along behind us are not going to be able to onboard to the web the way we did? Some of that scares me. I think we ought to be having more conversations about that. We ought to be talking about whether we've swung the pendulum too far in obsession of performance and lost sight of the fact that fundamentally what we do is communicate with our code. We don't instruct computers. Fundamentally what we do with code is communicate ideas. And if we obfuscate that process so much in the effort to shave off another microsecond of performance, we risk the fact that people won't be able to learn and do what we do. And that's an existential threat to our industry. So those are conversations we should be having. I'm not trying to predict doom and gloom, but I think a lot of people are just like micro-obsessed on, well, there's a new framework I got to go learn, and we don't have those bigger conversations about the ebb and flow of the web. And that, I hope, is where this talk sort of fits in, talking about some of the things that are happening in JavaScript. Specifically, the things that I've picked out are things that I think will help JavaScript be better at communicating ideas. Not doing new stuff that we've never done before, but doing the same things in better, more readable, more understandable ways. Because I think that's one of the most exciting narratives about the evolution of JavaScript. It is maturing along the axis of creating readable code. And I'm excited about that. I think that's a good thing. So without any further ado, what we're going to do is break this up into sections. I'm going to talk about a couple of features out of ES6, aka ES 2015, and then we'll look at ES 2016 and 17 and 18 as well. Okay? So the first one we're going to talk about is the rest and spread operator. It's a simple feature, and that's why I'm starting, because I don't want you to feel intimidated. This is not going to be a deeply, complex technical talk, or at least I don't aim for it to be. And then we're going to talk about iterators and generators. To me, those two, and these fit well together, to me, those two kind of represent the most important basis from ES6 that starts to carry forward into some of the things that happen in future revisions of language. I think when you take a step back, that may not have been anybody's favorite features out of ES6, may not have been the most exciting features out of ES6, but I think they were the most foundational things that got built on significantly as we went forward. So let's look at rest and spread. I don't know if anyone has written code like this before, but I can't even count how many times that I wrote code where I had a set of arguments that I was passing in, and I wanted to get that as an array, but maybe not all of them. I needed to slice something off. So we did this really stupid array.slice.call thing because of the legacy that the arguments object isn't really an array. We need it to be an array. So we make it into an array, and then I can put stuff onto the front of it. I can unshift values onto the front of it, for example. But then, once I have an array of values, and I'll pass those along as arguments to another call, we pull out our other friend, .apply. Now, the .apply method is quite useful. There's nothing wrong with the .apply method, but what I hate is that they conflated the idea of adapting argument lists to a call and specifying a this binding. Because I so rarely need to do both of those at the same time. I either need to do a this binding, or I need to do an adaptation of an arguments list, but I rarely need to do both. And yet we get one utility with both in it. So you end up with this stupid thing where you pass like null or undefined as a placeholder to basically say, I don't care about the this binding. That's a bad design. That's poor design. And I'm not trying to blame, they've got a lot of problems to balance, right? But on the whole, that ended up creating so much noisy, cluttery code. By the way, noise and clutter. I know everybody's favorite. You're surprised that I put the arrow function on ES6 because supposedly that's the best thing that happened in ES6. We cut out all that unnecessary stuff. The noise and clutter here has absolutely nothing to do with that function keyword or that return keyword. That's not the noise and clutter here that we're concerned about. Arrow functions are not the savior that's fixing all of our code. There's a whole bunch of other crap that we need to fix. ES6 arrow functions are at the very end of my list of things that I give any care about. Okay? Saving a few characters here and there, and then removing all the visual clues that used to signify the boundaries between things. I don't think that's a net win for readability. But we can fix some of this stuff, and in fact we did. We introduced the ... operator. It has two symmetric operational modes. One operational mode is that it gathers things together into an array, and the opposite mode is that it spreads things out into individual values. I like to refer to it as gather and spread. For some reason, they ended up calling it officially like spread and rest. They used the noun form and the verb form. I like to use two verbs that mean the opposite of each other, gathering and spreading. Okay? So, how could we rewrite this code to do the same thing, but to use this new declarative style of gathering and spreading? Well, first, let's gather all of the arguments up that we don't articulate as parameters into an array. That's what ... in the parameter list is doing, is it's gathering those together into a real array. And then, whenever we want to call another function call, let's do ... again, but this time we're going to spread out. So you see both usages of the ... They're symmetric in that they either gather or spread depending on their context. How do you know what the context is? This is getting a little bit technical, but if the ... operator is used in a location that's like the left-hand side of an assignment, it's like the left-hand side of an equals where you're assigning something. It's called an assignment context. And if the ... is used in an assignment context, then it gathers. If it's used in a value list context, like for example, the comma-separated values in an argument list, then it spreads. So you just have to be able to identify, is it a parameter list, like parameters get assigned arguments? Is it something that's receiving an assignment, then it gathers? Is it something that's spreading value, that's listing values out, then it spreads? That's really all you need to do to understand that ... Some people would rather have had different operators for those two usages. I like the fact that it's the same operator because the symmetry holds very strongly if it's the same operator. That's helped me to learn it. Maybe it'll be the same for you. Okay? Now this code does the same thing as before, but you notice that all the cluttered detail has been taken out of the code. It's being handled by this syntactic construct, the spread and gather. The idea there is this is a more declarative style of code. It declares that what I want is the end result that all those are gathered into an array. I don't care how that happens. JavaScript, you go figure that part out. What I want is for all those to be gathered together. Make it happen. That's what we think of when we think of declarative. Instead of code that focuses on how to do something, it's code that focuses on what the outcome is and why we care about that outcome. That's the difference between declarative and imperative. So the narrative I'm telling you is that ES6 is maturing along this axis of being more declarative. I think that's a really good one. Okay, iterators and generators. You're going to start out looking a little bit more imperative, but I'm going to make the case sort of in a closing sense that these are a more declarative style for dealing with operations across sort of a data set. We'll just sort of generalize the idea of a data set, okay? So if I had a data set that was a string or an array, and I wanted to deal with the individual items, I wanted to do some operation across all the individual items of that, one nice thing that ES6 codified is the iterator pattern, which is to treat something as a data set that we can deal with value by constructing an iterator and calling .next on it. That's kind of manual and imperative, so they created syntactic forms that know how to consume iterators automatically. One of those forms is the for of loop. The for of loop takes an iterator, like the one I've constructed here. This is an iterator instance on, an iterator view on that string, if you will. I'm going to loop over the iterator and get all the individual characters out. But I also can just loop over the value itself, because an iterable, that is something that can be iterated against, has the same interface to it as an iterator. An iterator is an iterable. Okay? So I can either construct my own iterator if I care to, or simply loop over that. Now, the reason I bring this up is because that thing I just showed you, the ... operator, when used in the spread context, it's spreading things out. Most people think it's spreading out of arrays, but actually what the ... does is it consumes and spreads out the individual values of an iterator. That's what ... does. It consumes the iterator exactly like the for of loop consumes the iterator. So we have these nice declarative syntax forms that handle that imperative iterator interface for us. The equivalent of that for of loop would be a whole bunch of messy .next calls and checking the done property on the results and all that other stuff. We don't want to do any of that. Just consume the iterator and give me the results. Now, an iterator might be attached to a string or to an array. It could be attached to a result set from a database query. Any data source, both hard data sources or virtual data sources, can expose an iterator interface, and then all of a sudden we can use ... and for of loops to consume them. And if the built-in values of JavaScript can do that, then so can our own custom values. If we opt into the iterator interface, all of a sudden our values are consumable in exactly the same way. Hopefully you can see why that would be a compelling way to, sort of a way to standardize on a particular way of consuming data. Maybe the iterator interface isn't your favorite way, but at least we have a standard that's codified into the language. We can all agree on this as a good interoperable way for communicating operations across a data set. Speaking of making our own values iterable, most of the built-in things, again, the arrays and strings and maps and sets and all those are already iterable. Well, let's say you make your own object. It's a data structure that has some kind of data in it. Maybe it represents a database query, maybe not, I don't care, but you make some kind of object in your application that's a data structure, and you want to make your object iterable. Problem is that objects by themselves are not iterables. They don't adhere to the interface, so you're going to have to take the extra step to opt your object, your data structure, into this iterator interface. Okay? So you might define some kind of crazy, function that makes an iterator object and returns it all, but actually turns out the generator is a nice declarative way to get an iterator. A generator is a special kind of function, signified by the star symbol. A generator is a special kind of function that represents in itself a data source. And when you interact with a generator function, when you call it, what you actually get back is an iterator. You don't actually run the function, you get back an iterator. And you can call .next on that iterator to step through the generator one step at a time. Just exactly like conceptually I talked about stepping through an array or a string or a map or anything else. So a generator is like a programmatic data set. And it exposes itself through the same interface as the other iterators we talked about. Which means that iterators that come from generators can be consumed in exactly the same way. The ... operator, the for of loop, array.from, and all those others. If you expose something as a generator, it will give you that iterator interface and give you the ability to consume it. So here's me making an object that allows me to consume the values from my obj object by simply calling this bracket key. I'm saying I want to, so I get my array of keys. Object.keys is going to give me an array of my keys. I'm just going to loop over all those and yield all of those out. And under the covers, this iterator can be consumed by a ... or by a for of loop. It's going to call .next and get the 1 value, and the .next to get the 2 value, and .next to get the 3 value, and then it's done. So I have that standardized interface for consuming what in this case is actually programmatic data. Any data that you can imagine, whether it's hard data like from a result set or programmatic data that's being generated like I'm doing here. The iterator interface is actually very powerful for declaratively standardizing the consumption of data. Okay? So, again, very, very brief glimpse into ES6. There's a whole bunch of stuff that I skipped over. But those two together happen to provide a good foundation for some of the stuff that we'll see in a little bit. Let's move forward into ES 2016. By the way, just as a little special note on those names. You know on the previous title slide I had ES6/ES 2015. The name of that language version is ES6. If you call it ES 2015, you are wrong. Okay? I don't care what any of those people on TC39 say. Those of us that wrote books with the word ES6 in it, we get the final say-so. That's what the language was called. It was called ES6. You can't come back and change my book title after it's already gone to publish. Okay? But starting after ES6, if you call it an ES7 or ES8 or ES9 or whatever, you're also a monster. Stop doing that. It's called by the year now. So after ES6 came ES 2016. There is no such thing as ES7. Stop calling it that. It's just more confusing. Doesn't help any of us out. It sounds hipster, but it's not cool. All right? ES 2016 is what it's called. Now, the change set of ES 2016 was massive 2 features. They were so hungover from ES6, which had like 5,000 features, that when they got to ES 2016, and it was the first of their yearly revisions, they're like, just whatever's like left over. It's like a rounding error. Just put a couple of features in and call it a day. So there were only 2 features, and I'm only going to show you one of the 2. Okay? There were only 2 features in ES 2016, a really small change set, but a useful one nonetheless. Okay? Array.includes. Now, this was not the original name for this function. Originally, this was called contains. And then they had to change it to includes because some dipshit in some library 15 years ago decided to extend the array prototype. Stop doing that bullshit. Stop extending native prototypes. You are breaking the future JavaScript when you do that. You're probably killing little Tweety birds or something too. Stop doing it. Stop extending the native prototype. This is one of many examples that we have where they had to alter the course. Now, includes is still a pretty good name, but sometimes we have the whole like, are we going to call it flat map, or are we going to call it array smoosh, or what? Like sometimes we can't come up with any other name because you take all the good names. Stop doing that. Okay? All right, array includes. If you've ever done index of to search in an array for some value, and you've compared it to -1, because what you were really doing is just trying to get a Boolean true or false. Is this thing in the array or not? I'd say that's probably like 99.100% of the reason we ever used index of. You almost never need to know its index. You almost always just want to know, is it there or not? And so you do this weird, like, comparing to -1 thing, because somebody back in 1970 decided that functions that don't find stuff should return -1, so why not do that in JavaScript as well? This is terrible, okay? This is the height of leaky abstraction imperative code to compare to -1. It only took us like 20 years to decide that we should make a Boolean function for this test, and that's what array includes is. It searches for something, and it returns you true or false if it finds it or not. Okay? So if I have this array of values and I call .includes on it, I get a true, I get a false. In fact, they threw out a few extra features, like I can set the index for it to start looking at, and I can even have negative indexing from the end. I never thought negative indexing was a good idea, but hey, some people love that. There's one extra thing, one little nuance, but it's important. Index of uses a test for a value that is equivalent to the triple equals. Under the covers, their algorithm is basically, it's not actually, but it's equivalent to the triple equals. Okay? There's a problem with the triple equals. It lies. The triple equals operator, I know all of it, I'm dashing your hopes because all of you have pinned all of your hopes of JavaScript on the triple equals. But the triple equals lies. Specifically, it lies about NaN values and it lies about -0 values. And if you don't believe me, go read the spec, because it literally says, if it's a NaN, lie. If it's a -0, lie. That's what it says. Go read it. Okay? It lies. And lies are not good for programmers. It's not a good idea to design systems that lie to us. This was a horrible idea. So what they did was they're like, all right, so we have double equals, which nobody likes, and now we have triple equals, which is lying. All right, let's just do like a quadruple equals. It's kind of like the mock razor, they just keep adding more blades, and at some point it's going to shave your face correctly. Just keep adding equals on until we get real equality tests. That's the algorithm that's used under the covers with includes. It doesn't lie. So when you say includes NaN, it says true. Even though a triple equals test with NaN would fail, if it finds NaN, it returns true. If it finds -0, it returns true. So now we have a test that actually doesn't lie to us. That's why you should stop using index of. Start using .includes. So that's actually a pretty cool part of ES 2016, even though it was largely overlooked by most people. This is a lot better than all those index of checks that so many of us have written. All right, moving along, ES 2017. More features this time. I'm still only going to point out like 1 or 2 of them, okay? Because we're limited on time, and also you're probably going to get bored and want to go eat drinks, and I do too as well. So let's just stick to like the stuff that kind of fits with this narrative that I'm trying to tell, okay? So I want to look at async await. Now, if there's anything that developers have gotten more excited about than the fat arrow function, it's the async await. I've never seen so much hype around the async await. And it's largely with good measure, like largely well placed. It's a good feature. It's not perfect. There's a particular downside that I don't like that we're going to talk about in just a moment. But it is a really good feature for fixing what was otherwise just nonsense design of the promise API. Promises themselves are one of the best things ever added to JavaScript, but the API is one of the worst designed APIs I've ever seen. I try not to ever deal with the promise API. I use promise all the time, I don't use the API. And the pattern that async await enables allows you to do that largely. So it's a good thing in my book, but it does come with some downsides, okay? So async await. If you're not familiar with the idea of an async function, you really have to almost think about it in terms of a generator that I talked about before. Because actually it's sort of like syntactic sugar on a generator. A generator, remember I said it's this special kind of function that can yield out values. Well, the implicit thing that we didn't talk about is that when you yield out a value, the generator pauses locally inside of itself when it yields out a value. And it waits to decide to see if somebody's going to resume it with another .next call. So inside of the generator, it's like it's paused the whole JavaScript work, but it didn't pause everything, just inside of the generator. Understanding that concept allows us to understand why async await is useful. When we have a concurrent, aka asynchronous operation that needs to occur, what we're really saying is, hey, go make, like, for example, an AJAX request. Go make this AJAX request. What I want is the response. Now, I don't want you to block the whole UI thread. Be responsive, be non-blocking. But from a programmer perspective, why should I go to all the trouble like spell out this big long promise chain crap like this to tell you that all I really want to do is wait for the response? Because if you think about how our brains actually work, our brains work fundamentally step-by-step sequentially. We think about do this, then do that, then do that. And if there's a blocking step implied between step 1 and step 2, our brains are quite happy to reason about that. We can't allow the JavaScript engine to block, but it would be nice if we could think about our asynchrony in a fundamentally synchronous fashion. Do this, and I'll wait. I'll locally wait as long as it takes to get the answer. And then do this, and I'll wait, and then do this, and I'll wait. To do it with a promise chain is all this ridiculous .then and the function wrapping and promises inside of it, promises, all that stuff sucks. Okay? It's a horrible API. Here's how we do the sync-async pattern using async functions. We say, hey, go off and do that thing, and I will locally pause. I will await the response to that AJAX request. Inside of this function, it pauses. The rest of the program does not. But inside of the function, it just pauses, which is why we can use this magical equals sign. I didn't know that equals was magical, but it is. It's magical because it's the synchronous form of assignment. What is the asynchronous form of assignment? Callbacks. Ugh. Synchronous assignment is how our brains work. We think, hey, go off, make the AJAX request. It's cool if I need to wait a little bit. And what we've done is given ourselves a style of programming that fits closer to the way our brains think. Hey, it's cool, I can wait on it. Take as long as you need to. Right? Inside of the function. It's critical to understand it's not going to block the whole program, only inside of the function. So I'm explicitly saying here that the stuff that comes on line 4 should not start until after line 2 finishes. I am awaiting the results before I go on to the next step. If I need to do a couple of things in parallel, I can still use promise.all. But I can either do sequential or concurrent asynchrony in a synchronous looking style. And by the way, I will show in the code, but you can also do error handling. You can wrap a try-catch around an await statement and catch synchronously what was an asynchronous exception. It's magical. This is a far superior style to anything that the promise chain API folks have brought to us. Maps clearer to the way that we think. It's more familiar to many people who have worked in fundamentally synchronous environments. We get the same benefits, but we just annotate the places where it's okay for a local pause to occur. That's what the await trigger does. Okay? So, this is a far better style than anything that came before in terms of asynchrony. But there is a downside to us building that into our syntax as opposed to doing the same kind of thing with generators. I don't have a code snippet for it, but you can do the same thing with a generator that we just did here, but you need a little runner to do like the pause resume stuff. So as soon as ES6 came out, a bunch of us that were like really interested in asynchronous programming started doing all this style code, but with generators and these runners wrapped around. And then a bunch of people started bellyaching, oh, it sucks that I have to load a library to do it. Can you just make this feature built in? So they did. They built the feature in, so you don't need the library anymore. Anytime somebody says, hey, can you just make this feature built in, instead of me using a library, what you should hear is, hey, there's like 80% of the use case that I want you to build in, and this other 20% use case you're going to screw over. That's what happens. You have to simplify to put something into a language. They could not handle all the use cases. So they decided that there was some use cases that they cared about, which is pretty good. And then they said there's some other use cases that we don't really care about. And that's where the rub is, right? Because what if the use case that they decide they don't care about is actually really damn important? What do? We're sort of locked out, right? These become a black box. We're not in control like we were with a generator. With a generator, you have full control to pause and resume and do all this other stuff, but you don't have any of that control with it. This is a black box. You start the function, you call it, and it runs whether you want it to or not. You can't stop it. You can't step into the middle of it and alter its path. You can't do anything. It's just going to run until it finishes. For the 80% use case, that's good enough. And that's why most people are using async await now. But there's a kind of important use case that it's missing out on. That's what I'm going to get to in just a second. I want to talk about some of the problems that these have. Now, The first of these are maybe nuanced, maybe you don't care that much, but this third one I think is a bigger deal. All right, so the first one is that the await keyword only knows how to work with actual promises or things that look like promises. Most of the time you're only using promises, so that's not such a big deal. But sometimes it's convenient to be able to await other sorts of asynchronous abstractions, like for example funcs or other things like that. We had that freedom when we were working with generator runners. Many of the generator runners allowed you to yield out a func or some other kind of representation, and they were smart enough to know what to do. The await keyword is not smart. It only knows how to work with promise thentables. That's it. So there's some use cases that we lost in getting just the built-in syntax. Okay? Maybe not such a huge deal, but kind of stings if those were use cases that you cared about. Another one, even more esoteric, but this one I actually ran into. This is not just like a made-up situation. If you've ever dealt with any kind of concurrency or parallelism, you'll know about the term starvation. The idea that a parallel system or a concurrent system can experience starvation. Basically what we're saying is if you have these two different pieces that are spinning independently and one of them gets really greedy with resources, it can starve out those resources and prevent this other piece from ever getting a chance to run. Starvation is kind of a bad thing. It's bad when it can be malicious, and it's even worse and more subtle when it's an accidental starvation. Because you're trying to debug this thing over here and it's never running. You're like, why is it never running? Well, it's because this thing over here is eating up all the resources. So starvation is kind of a big deal for those of us that have dealt with like parallelism and concurrency and things like that. It relates to the scheduling algorithm of how you schedule things. There are scheduling algorithms, more like round-robin scheduling, that essentially can defeat many of the common cases of starvation, both malicious and accidental. When you write a generator runner, you have the choice to put in a more intelligent scheduling algorithm that prevents things like starvation. That's what my gen runner did, that's what many others did. When we put the scheduling algorithm into the JavaScript engine, for some reason they decided not to care about this particular use case. So the promise thing is sort of first come, first serve. And we have this microtask queue that creates a very realistic scenario where either on purpose or accidentally, you create starvation between your async functions. And I've seen actual code bugs in the wild that happen because of that. I was trying to use async functions with this pattern called CSP. Starvation is a big deal with CSP, and async functions have no answer for that. Just you get what you get with what's built into the engine. That's another one of those that's not going to get all the headlines on blog posts, but it bothers people like me that pay closer attention to these things. But it's the third thing on this list that bothers me the most. It's kind of almost a deal breaker for me for async functions. No external cancellation. The idea that if I fire off an asynchronous operation and then halfway through I decide I don't care about the rest of that operation, I ought to be able to tell it, hey, stop doing what you're doing. With generators, and when you're in control of the scheduling algorithm and all that, you can tell the generator, hey, stop. I know you're halfway through doing that whole like Ajax thing or whatever, but I don't need the result, just stop. With an async function, there's absolutely no way to do external cancellation. You fire off an async function and it just runs until the promises are finished. You may have seen problems like this where you fire off an Ajax request, it's like a long download of a gigabyte file, halfway through the user doesn't want it, sorry, tough luck. That thing's just going to keep going. Now, it's not that they didn't think about this use case. They actually did think intently about this use case. I was part of the discussions around this particular use case. And I was part of saying, hey, this is like a really important thing that we should fix. In the design of async await, before you ship it, you should have some mechanism built in that allows for external cancellation. And their answer was, for years, oh, it's cool, we're just going to do cancelable promises. In other words, the promise that you get back from an async function will let you call .cancel on the promise, and that'll magically send the signal into the async function to tell it to stop. So me and a few other people that know what we're talking about, that's a terrible idea. Don't do cancelable promises. That is an abomination to the design of promises. It completely invalidates the whole reason why promises are great. Do not do that. We spent 2 years arguing about cancelable promises on various thread lists. And finally, they wisened up and they're like, you know what, cancelable promise is a bad idea, let's not do that. So they abandoned cancelable promises, but by that point, async await was ready to ship. So they're like, oops. We don't have any answer for cancelable async functions, so that use case just got swept out the door. Okay? Now this is a huge problem if you're doing lots of asynchrony and you care about being able to manage your resources and the CPU time that's being spent on stuff. You really need the ability to cancel it. Your only option with async functions is to architect this very intrusive mechanism where you like set a Boolean flag and check the Boolean flag every so often. And, like, there's no way from the outside to just tell it to stop. This is such a big, important use case that I decided to make a library to make this better. CAF, which stands for Cancelable Async Flows, uses generators, but it makes them look like async functions. In other words, you get a real function that you can call, you get a promise back, it looks like an async function, but under the covers, it's a generator. So you just have to like use yield instead of await, but that's about it. But the main difference is that a CAF wrap function accepts a cancellation token. You pass in a token from the outside, and then if you later decide to abort that token, the CAF wrap function stops immediately. So you get the benefits of the asynchronous style, but you get cancelability instead. Cancel tokens is what they ought to have done. This is not, I didn't invent this idea. Really other smart folks did it, and I just adopted it. But they didn't build it in, and so I'm left saying, anytime I need a cancelable function, I have to use this style instead of using async await. Okay? Maybe that's useful to you, maybe not, I don't care. It's fine. But I think cancellation is kind of an important use case, and I think it's a bummer that we lost out on that use case being handled by the language. Okay. Finally, earlier this year, we got another change set that was added, ES 2018. Now, there were several little things that were added that I'm not going to cover. Two things that I think are kind of important. One, a bunch of improvements, finally, to regular expressions. How many of you like regular expressions? Anybody? Okay, good. That's more hands than I expected because most people don't like them. Whether you like them or not, they are very important and very powerful. And whether you like them or not, JavaScript regular expressions have sucked for a really long time. They've been like decades behind other languages. Finally, we're getting some better features added to regular expressions. There's still a long way to go, but we're getting some really important stuff. And then I'm going to finish tonight by talking about a curious new addition called async generators. It's like the love child of async functions and generators stuck together. It's going to be pretty cool, but it's going to take some figuring out of the use cases here because the early things that I see from bloggers is very off track. But anyway, we'll figure it out. It's a good feature. All right, so improvements to regular expressions. First off, we now get look-behinds. I don't know if any of you have ever dealt with the frustration that JavaScript regular expressions only have look-aheads and not look-behinds. We have both positive and negative look-behinds. Thank you. One person gives a damn. It's really important to be able to write a regular expression and have it have a look-behind context. A look-behind just means if I'm matching a thing, make sure it either does or does not follow some other pattern. Look behind and assert that it either does or does not match some other pattern behind it. Okay? We've had look-aheads forever, but every other language on the planet has had look-behinds, and now finally JavaScript has them as well. That's a huge win. Even potentially more useful for readability, we now have named capture groups. If you've ever worked with capture groups and you have like \3 in your regular expression and they're like, oh shit, it should have been \4. Now we get to name our capture groups so that they actually have semantic meaning to them. You put a name on it, like I put cap here, I'm just trying to save space, but this is like a name for that capture group, and then I can access that on the result object by property name. So down here I can access, where is it? Oh, there we go. So there's an object that comes back called groups, and on that it has a property called cap, which is the name of the capture group that I have. So now we can name those capture groups and no more of that like \3 weirdness that we've been dealing with. Okay? So there's other improvements, like we got .all and some other things like that, Unicode features and stuff like that. But those are two major features that are long awaited for improvements to regular expressions. I hope this signals that we're going to get even more improvements because there's a lot of other stuff that need to fix too. All right, our final feature we're going to look at is this async generators. Taking the async function, the best of what's good about async functions, and taking generators, what's the best part about generators, and putting them together. Unfortunately, this does not mean that we somehow magically get cancelable async functions. I wish that's what it meant, but it doesn't quite mean that. But it's better that we have this feature. This is kind of a missing feature in JavaScript. It fills out the grid, if you will, of the quadrants that we've needed. We've had this missing quadrant of handling certain kinds of asynchrony, and now we can handle it properly. So this is a much deeper detail than I could go into in our short little time together. But if you look right here, I have an await that's awaiting a result, right? I'm awaiting an AJAX request. But I also have a yield here. So I have both await and yield in the same function. What's happening here is I have two different use cases happening. I have a push and a pull at the same time. I'm pulling a piece of data from some asynchronous source, and then I'm pushing that data out through an iterator interface. In other words, what I'm doing is allowing myself, we talked about iterators at the beginning. An iterator is synchronous. I call .next and I immediately get a result back. Call .next again, I immediately get a result back. But what if you called .next and it had to do some asynchronous work before it could give you a result? That would be an asynchronous iterator, right? It's this missing gap in our feature set of JavaScript. Async generators are how we create asynchronous iterators. Okay? You remember how iterators could be looped over with a for of loop or a ... How are we going to loop over asynchronous iterators? How are we going to consume asynchronous iterators? Well, you might think, oh, I can just make a while loop, like a while true loop, and I can await my call to it.next. Now, something very important to understand. It is not that we're getting a result back that includes a promise. It is that we're getting a promise for the result. It's different. We've always been able to yield out a promise, but now the .next call itself returns us a promise. So we need to await the promise for our result. And then once we have the promise resolved, then we can ask, is my iterator done? What's my value? And so forth. Okay? Now, this while loop will work all day. We'll be able to consume an asynchronous generator, an asynchronous iterator just fine. This is ugly and imperative. We like nice, clean, dedicated loop syntax, right? So let's invent a new loop syntax called the for await loop. The for await loop knows how to loop asynchronously over asynchronous iterators. So we can define asynchronous iterators with our asynchronous generators, and we can loop over our asynchronous iterators with the for await loop. We finally have a full and complete picture of what we need to model all forms of concurrency management in JavaScript. This is the missing piece that will enable us to implement much more sophisticated patterns. This is almost syntactically equivalent to an observable, actually. There was discussion about whether observables were going to be added natively to JavaScript. I'm not sure if they will or will not, but my understanding is that currently they're thinking maybe we don't need that feature because you can build observables with asynchronous generators. It was that missing piece that we didn't have for a long time. So asynchrony has really grown up. It's really matured in JavaScript. For those of us that have been struggling for a long time with callbacks and promises and all that other stuff, it's nice that we finally get to a point where we can see over the horizon a more mature state for asynchronous management of our code. So that's what I have for you in our discussion of the recent stuff that's been happening. Again, not a complete, exhaustive list of all the things, but that's what I've come to believe is kind of the important stuff that you should be paying attention to. Remember that the narrative I'm really trying to tell is not that, okay, well, we're done and we can move on to other things, but that this is a continual thing. TC39 is already working on a whole bunch of cool stuff that's going to come up in ES 2019. Probably not going to make it in ES 2019, but exciting stuff that I'm looking forward to. We're thinking about getting pattern matching. That's pretty awesome. If you've ever worked with pattern matching in other languages, that's a hugely important declarative thing. And now we have a proposal and we have a champion for it. It'll take a couple of years to work its way through, but I'm super excited about that. So get involved with what's happening with JavaScript. Be part of the recent parts, is really what I'm trying to say. Provide your feedback to the TC39 members. They do their work on GitHub, so you can see what they're working on and file issues and provide feedback on those proposals. File an idea on ES Discuss if you have a feature that you think JavaScript should have that they're not talking about yet. Get on ES Discuss and propose it. That's what I've got for you. I hope you're as excited about the future of JavaScript as I am. I believe what Brendan Ike said years back is still true, that the bets on JavaScript are paying off pretty well. So let's keep pushing forward. I appreciate your time tonight. Thanks for Based on our timing, because I know we got about 15 minutes left, if there were any questions, I'll be happy to answer a couple of questions. Yes?
In your talk about the cancellation stuff, does that have, does that relate to the stage 1 cancellation proposal? Does it feel like it's being stalled out, or?
Stage 1 cancellation proposal?
Yeah. Proposal cancellation, TC39 stage 1.
I think that's I'm not positive, but I think that's a proposal on cancellation tokens.
Yeah.
Okay. Problem is they already shipped async await, so no matter what they do with cancellation token, they're going to work for async await. That's the problem, right? They should have done that 4 years ago before they shipped async await. Then we wouldn't have the problem that we're presently faced with. Yes.
Yeah, in your for await loop, you had a console log.
Yeah.
Will that happen like, it'll happen now, and then the next time it returns, it happens again? Or
yep. The loop itself will pause itself while it's waiting for a result from the iterator, and then it'll run and wait and run and wait and run and wait.
Very cool.
Yep.
Just on the comment that you don't need observables. What if you had multiple subscribers, I guess, to this thing? How would you handle that with that type of a loop?
So I wasn't trying to suggest that it's like a complete, in itself it's a complete, it's the building block upon which you could build observables. But the idea behind an async iterator is that you can construct multiple instances of an async iterator and push those values out. So you could build an observable with an async generator, and each iteration instance that gets created just push all the same values. Same thing as having multiple subscribers to an observable. So out of the box, it's not an observable, but there is enough there that you could build an observable out of. That's what I think. Yes?
The languages for, like, say, ES 2018, who's implementing it, and is it across the board? Like, there's transpilers and stuff like that that implement things that are not there yet?
Yeah, so we have a pretty good mature story around transpilers, Babel especially. We have a pretty good story that they implement support for that when it's at like stage 0 or stage 1 support, years in advance of whenever it lands in the spec. Part of the TC39 process is they want essentially developer feedback, if you will. Like developers to have used the thing to see whether or not it's a good design for the thing. So by the time it lands in the spec, it's already been used by people that have been using those transpilers. And it's also been implemented in at least 2 browsers. That's also required by the TC39 process. So by the time something made it into ES 2018, it was already multiple years of support in Babel and shipped in at least 2 browsers. So it's a lot better than what it used to be, where like something comes out and we might have to wait like 10 years until it shows up. All right, well thanks very much. I appreciate you being here. Have a great evening.